All right. So before we start, what I'm going to do is I'm going to go through all these, review them, and this will be for Monday. But before we do that, I want to talk to you about something that a good friend of mine, I've known him since 1985, maybe 84. He and his family live in Florida, and his son, he has some kids, and his oldest son is 10 years old, but when his oldest son was 18 months old, was diagnosed with type 1 diabetes, which is juvenile diabetes, which is a pretty horrific thing. So in order for them to raise awareness and raise money, they're doing this. It's called Noah's March. And they are walking from the Florida Keys all the way to the state of Washington.
Walking?
Walking.
Oh, God. I couldn't do that.
It's almost 4,000 miles. So let's see.
That's hats off.
They're gonna walk through Colorado.
Yeah, they'll come through Colorado. So if you go to the interactive,
Like 3 months.
oh gosh, no, they'll be done like in October.
Oh.
So they started January 1st. I mean, they are still well into Florida. Okay, so
Can you join them?
what they'll do is right now they started on Sunday, January 1st, and it's 3,925 miles that they have to walk. Come Saturday, they will be in Key Largo, Florida, and they'll say how many miles they've completed and then how many are left to go. And then they'll be in Fort Lauderdale. So they are walking across the United States.
Denver, Colorado.
They'll be here in Denver Saturday, July 8th.
Wow.
Or is that their plans, or is that what
Woo!
they're going to do?
So almost a month later, they'll be in Salt Lake.
You know how much weight I would lose?
I mean, but just go and fathom this. Noah is 10. He's 10. He's walking across the United States with his dad.
Oh, it's just
I mean-
your dad.
Well, the mom and the other kid the other kid would probably be walking a little bit here and there as well. But they're like in a motorhome, so they'll go, so they're homeschooling their kids this year in order for them to do it. What's that? Yeah, but I mean, just going.
Are they moving to Washington, or are they
No,
going
no,
back to
they're
Denver?
just doing a walk across the United
Are
States.
they gonna drive back or walk?
Just
back?
casual.
I think they'll drive back. But I mean, but take a look. Their last day is October 28th in Blaine, Washington. I mean, just fathom y'all know that if you go on a road trip, there's road trips that take a long time. This is a walking trip. Just think of that. I mean, I feel that, I've been kind of following them a little bit. They've got about 40 people that have joined them on this walk so far. And it just started January 1st.
No, like,
I'll join.
can the kid quit if he literally can't go on anymore?
No, they're going to make him die, and they'll bury him on the side of the road.
Yeah, Rob.
I have no idea. Rom?
Shut up.
Sometimes. No. No. Plenty of people have walked across the United States, but I mean, it is something that people genuinely do. But I mean, you just think about this: going from the most southernmost point of the continental United States to the state of Washington. So just think about this. So when you start hearing, "Hey, we got this kid walking through Colorado, walking across the United States," I mean, if you go out there and cheer them on, I have no idea what route they're walking through Colorado. It was funny, I was talking to my dad last night, because my dad knows Robert. Robert's the guy I grew up with. And my dad was like, well, let's just swing through Phoenix. Dad, you realize that's 800 miles out of the way, and they're walking? Maybe you should go and support them on their route. So on each of these Saturdays, they have a 5K run. So this coming Saturday in Key Largo, Florida, which will be like 80 degrees, they have a 5K run to raise awareness and money for type 1 diabetes research. So, pretty amazing. Pretty amazing. Go to Florida? Let's go. All right, so let's go to the systems. Problem number 1. Problem number 1. Did you choose to graph it?
Yeah. No. Substitute.
Substitute? I think graphing would have worked as long as you did this. Let me know what did I do right here? What did I just do? Just subtracted 1. Now is it set up to graph okay?
Yeah.
I think so. Now, if you chose a different method, that's fine. Okay, so this one will be at -1, and then I go down 1, 2, 3, down 1. And then my other equation, we'll do in purple. 1, 2, 3, and 4. And I go down 1, right 2. And here's where the intersection is, which, what do you think? -2, 5. Let's see if that works. If I plug that in, that's x and y value, right? This is an x, that's a y. If I plug that into my both equations, it should work. So I get 5 plus -6. It's 5 plus -6, -1. Works on the top one. Let's plug it on the bottom one. So I get 5 over here. What is half of -2?
1.
Negative half of -2. Positive 1. Positive 1 plus 4 is 5. Y value is 5. Boom. So that might have been a good one that you could have used graphing on. Okay, again, but if you have a straight edge, it's going to be a lot easier for you. I freehanded it and got, well, it looks like my graph is pretty close to that for a freehand. So should you choose graphing on this one? I don't know, maybe. But sometimes you have to realize you have to modify it and make it y equals. Or if it's in standard form where it's like 3x plus 2y equals 12 or something like that. Yeah.
Are you fine with us changing the equations
To satisfy and make everything y equals 1, x equals 3? Yeah.
Fine?
Yeah, and that'd be, yeah. You just change the problems to make it most comfortable for you. I don't think you realize my sarcasm.
No, actually.
All right.
You were sarcastic.
Yeah, just a smidge.
Oh.
All right.
I didn't notice that.
Does this one seem to be a good one to graph? The bottom equation seems fine. But the top equation, we did the cover method. I would get the x value being 1/3. I get the y value being -3. So I guess it'd be -1/3 and -3. So graphing might not be the best on this because the top equation is not as conducive. So what's starting to stick out to you would be a good method to solve this? Substitution, because we have a variable equal to something. We know this, I can plug that in right there. Okay? So if I get 6x plus 2, there was a y there, and I'm going to plug -3x plus 1 in instead. What do you think? Distribute over the parentheses. So 2 times -3x is -6x. 2 times that is 2 equals 2. The x's are gone, so I get 2 is equal to 2. What does that mean?
Infinite solution.
Yeah, that's a true statement. All of our variables went bye-bye, so we have infinite solutions to this problem. Okay, if you had graphed this one, they would have been parallel lines. Parallel lines don't intersect. That's why there's not a solution. The solution is where they intersect at. Any questions on the first two? Number 3. Elimination. This one seems to be set up nicely. The x's and the y's are lined up with each other. Now I might need to figure out a value to multiply, so I'll have to pick either the top or bottom. Maybe I'll pick the top one and multiply everything by -1. So we'll distribute there and there and there. So this top one becomes this. And the bottom equation just stays as is for right now. If I add these together, the x's are gone, the y's are gone, so I wind up finding the mystery of the whole world that now 0 is equal to negative 6. That's not true, is it? What can you tell me about the solution then? So no solution. So this one would have been parallel lines. I made an error in my speaking. If this was graph, this would be the same line on top of itself. So parallel lines are no solution. Same exact line is infinite solutions. Okay. System 4. What seems like a good one? Substitution. We know we have a definite value or letter or variable equal to something. So I can take this and plug it in where? Where does that get plugged in? At the x on the other equation, so right there, correct? So if I modify this, I'm going to get 3 times 3y minus 5y equals 12. 3 times 3y is 9y, is that right? Minus 5y equals 12. 9y minus 5y is 4y equals 12. Divide each side by 4, so y is equal to 3. Put it in the right spot because it's x comma y, so I solved my y value. What should I now do with that y value? Plug it back into one of the originals. Okay? So you're going to take this value here, and you're going to plug it in either right here or right here. Which one seems simpler? The x equals. It says we want to know what x equals, so I might choose this one. If I plug it in the other one, it's going to be the same answer. So I get x is equal to 3 times, it was y. What am I plugging in for y then? So 3 times 3 is 9. So my solution is 9 comma 3. Good. Love it. Seem okay so far? Can I move to number 5? System number 5. Does it appear graphing might work? Well, the top one would be okay for graphing with cover method. You get an x value of negative 8 and a y value of positive 8. But the cover method doesn't really work on the second problem. Agree? Does everyone see why it doesn't work? If I use the cover up, I cover up this value right here, I wind up with x equals 16 over 7. If I cover here, I wind up with y equals 16 over 5. So we have these weird fractional amounts. So the graphing might not work. It looks like elimination should work on this one. So which letter should we get rid of, x or y? Looks like it'd be better to get rid of the x first, or the y first, excuse me. So if I multiply this whole thing by 5, this becomes 5x minus 5y equals negative 40. And then this problem stays as is for right now. But now I can add the two together. What falls out if I do it this way? The y's are gone. So I get 5x and 7x is 12x. The y's are gone. Equals what? 20? Negative 24? So what is x actually equal to then? Negative 2. So I have an x value and a y value. Okay, I need to take that x value and plug it in to where I have both an x and a y. So I can plug it in right here or right here. Which one seems to be easier? Top does seem to be easier. It would be the same answer regardless. So I'm going to take this top one, and I have negative 2 minus y equals negative 8. Agree? That was an x, but x is now equal to negative 2. Add 2 to both sides. Divide by negative 1, isn't it? So that's our answer there. Okay? Any questions on the first 5? Everyone feel pretty comfortable about it? All right. Number 6. What do you think? Graphing? They're both y equals. Someone asked, if it's y equals and y equals, well, you could take this and set it equal to this and solve for the x, which probably could work. But I think graphing might work best on this one because they're both already set up. So what's my y-intercept there? 0. So I'm going to go up 1, right 2. And then this one, what's my y-intercept there? 2. up 1 and over 1. They're going to intercept each other. Do you agree?
Yes.
Anyone got an answer on it?
-4,
-4, -2. Negative.
Yeah, -2, -4.
I would think.
Because -4, -2 doesn't work on it. If you plug it into y equals 1 of x.
-4, -2.
Yeah.
That's what you think the answer should be?
Yeah, it works out.
Let's take a look. So that's an x and a y value, right? So my y value up here, I got -2 equals half of -4. Is that -2? It works there. What about on this one? I get -2 equals -4 plus 2. So -2 equals -2. Works on both of those. Yep, that's your answer. Okay? So your quiz on Monday, it's just a front and a back. There'll be some of the problems on the front side, like the very top ones will say use either substitution or elimination. So some of them will lead you to use one versus the other. And then after that, it'll say use the elimination method, and they have them kind of set up. You might have to go through and multiply. And then on the back side, it's graphing. So if you wind up with this for an answer, this means they would have crossed, and you have one solution. And the solution is the point. If you wind up with something silly like this, and your x's and y's fell out, what does this mean? Infinite solutions. So this would have been the same line on top of itself. Okay? And then if you wound up like this, what do you know about that? There's no solution. So what kind of lines other than straight would these be if there's no solution?
Parallel.
Parallel. If they're parallel lines don't intersect. If they don't intersect, that's why there's not a solution. Okay? How do you feel?
Pretty good.
Awesome.
Everyone's solid? Yippee skippy? Oh, we had homework,
Oh.
which was what?
163, 164.
And then wasn't there one the night before?
162.
Yeah, 161.
Yeah.
161 and 162. So there's 2 pages worth? Okay, I need those 2 pages. I need them stapled and your name on it. Put a staple and your name. And bring them up here. What's that? We're not worried about that weird challenge one.
So I did the other one in my locker.
Did you lock your keys? Okay.
I will just. I can get that tomorrow.
Well, I won't be in. Oh, so. Cool. Thanks, bud. As far as your assignment goes for tonight, it's going to be page 165 and 166, which is just review. Okay? So what I'll do is I will go over and mark this off on Monday. So that'll be your assignment for this weekend, okay?
Yep.